All right, today we are doing 6.6 notes, properties of logs. We're going to condense and expand logarithmic functions. So the product property says if we have log base b of m times n, it can be expanded to say log base b of m plus log base b of n. So when you expand it, you have to write the log out as many times as you have variables. So for this example, we have log base 2 of 3 times x. So we would write this out as log base 2 of 3 plus log base 2 of x. The quotient property says if you have log base b of m divided by n, you would write it out as log base b of m minus log base b of n. Any variable on the bottom should have a minus in front. So for example, log base 7 of 19 divided by x can be expanded to say log base 7 of 19. X is on the bottom, so it's minus log base 7 of x. The power property says log base b of m to the p power can be written as p, the exponent dropped in front, times log base b of m. So in our example, we have our exponent. We're going to drop it out in front, so it's 4 log base 5 of 7. So when you expand a log, you write it with plus minus signs and no exponents. But you can also condense where you go the other way, where you write it as a single log term. We're going to do both today. All right, so if we're looking at part A, notice these are being multiplied. So to expand it, we're going to have pluses or minuses and no exponents. We would write this as the natural log of 7 plus the natural log of x. For part B, these aren't being multiplied. We have an exponent to deal with. So the exponent goes in front, so the 2's in front. And then you have log base 5 of x. For C, these are being divided. So you would have log of x. The 3 is on the bottom, so it's minus log of 3. For part D, we have a couple things going on. The first thing is 64 is getting multiplied by x cubed. So we have to separate the fact that these are being multiplied with a plus sign. So you would write this as log base 4 of 64 plus log base 4 of x cubed. But then we have to deal with the fact that this 3 is here, this exponent. So this would drop in front of the log it's associated with. So this would drop down and the plus, but the 3 comes in front of this log. So it's 3 log base 4 of x. Now you might get to a place where you can skip that middle step and do it all at one time. If you can, go for it. Lots going on in this one. So we have log base 3 with the square root of x. And then these are on the bottom, so it's minus log base 3 of y squared. Z is on the bottom, so minus log base 3 of z. If you recall, the square root of x has an exponent of 1/2. So this is actually x to the 1/2. So dropping the exponent in front, it would become 1/2 log base 3 of x minus the 2 is going to come in front of this term, so 2 log base 3 of y. And this one doesn't have an exponent, so it just drops down. That's your answer. All right, for part D, we have log base 6 of 5. X is on top, so it's plus. Log base 6 of x cubed. Y is on the bottom, so it's minus log base 6 of y. This doesn't have an exponent, so it drops down. This has an exponent, so the 3 is going to come in front. So 3 log base 6 of x. And this does not have an exponent, so it drops down. All right, for number 2, we're going to go backwards where we condense each expression. So this will become written with a single log term without a plus or minus and without this 2 in front. So we're going to move this back to be the exponent of this term. So this would be written as log of x squared. Plus, this doesn't have exponent, so it stays this way. Then we have to get rid of the plus. By getting rid of the plus, it means we're going to multiply the x squared times the 5. So we have the log written one time, and that would be written as 5x squared. When you multiply a number to a variable, remember the number always goes first. For part B, we have log base 7 of 48. This 4 is going to become the exponent to the 2, like so, log base 7 of 2 to the 4th power. Now we have the minus, meaning we're going to make this be dividing. So I have log base 7 of 48 on top over 2 to the 4th on the bottom. Notice 2 to the 4th power is 2 times 2 times 2 times 2. So this is log base 7 of 48 over 16. Well, 48 over 16 can be reduced to 3. So that is our final answer. For part C, so we have one exponent to deal with, which is this 3 would be going here. Everything else drops down. So this is a positive, so it's going to go on top, get multiplied with 3 cubed, which is 27. This is a minus, so it's going to be going on the bottom. So 4 times 27 is 108, and then the 12 is the minus that goes on bottom. 108 divided by 12 is 9. For D, this is the exponent. It's going to go with the x, and it's going to go on top. So these are all going to get condensed to be a single log term of log base 5. Since this term is positive, x to the 2/3 goes on top. Since this is a minus, this is going to go to the bottom with the exponent 4 with the y value. And then the 6 is on top because it's a positive. The change of base formula is when you're changing a base to 10 or e so we can find the value using our calculator. Now your TI calculator has a math log base button, but you may not have the ability to do that. So what they did is whenever you had a base that was not a common number, you could rewrite it as log of m divided by log of b. It ends up, that's equivalent. Or if you wanted to, you could do the natural log of m over the natural log of b. You'll end up getting the same answer. So if I was to write this with the logs using the new properties, this would be written as log of 52 divided by the log of 7. Okay, so you can go to desmos.com/scientific, and then this will give you your main page, but if you want to click on the function tab, you can see over here that you've got your log and your natural log. So then you can type in that you're taking the log of 52. So we have to go back to the main to say 52. And then we're going to go outside the parentheses and then divide by the function of the log of main number 7. And then you can hit enter, and it gives you 2.03. For part B, we have log of 154, but just to see, you could do natural log. And then log over 5. You'll get the same answer. C, if you do the log of -2 over the log of 2, again, you can't take the log of a negative number, so this would be undefined. And then we have this one, we have log of 61 divided by log 1/3. You should get -3.74. For E, log of 1 over 73 divided by log of 4, you get -3.09.